In my 10 years, roughly, that I've been at Ivy Tech, I can tell you there's a handful of students that really have had a huge natural inclination for using software like this, and Justin is on the very short list of people that I remember as being truly exceptional. Justin's someone that I can show something to, and I come back even just a few days later, and he is 10 miles past whatever I showed him.
I grew up in the 80s and 90s when movies were made by hand, and all of the props were made by hand, and if you saw something beautiful, someone made it with their own hands. And I fell in love with that. I very much fell in love with that. As I got older and I started becoming involved with small makers and the immersive event community and the live action role-playing community, I found that I had a bread and butter item that I could make reliably, and so that is really why I decided to make props. I've actually been out of school quite a while, from high school and the military and such, and I was running a pretty successful business, and in 2012 I started having problems with my hands. It got so bad to the point to where I had to wear braces on my hands 24 hours a day. It took 3 to 4 years to really figure out that I have rheumatic arthritis. Because of that, I have a hard time using the tools that I used before in my trade, because mechanical vibration translates through your hands and agitates arthritis. So I wanted to come back and learn how to make the robots do it.
I love working at Ivy Tech Community College and teaching our students just because I love hearing what their stories are. We have a lot of non-traditional students at Ivy Tech, and it's always interesting to me to meet a new person and see where they came from and how they ended up here and what their goals are, and really coaching them through that process. The skills gap to us basically means that students come in many times with not a lot of technical background, if any. They may have a very good traditional educational background, but they haven't spent a lot of time making like hands-on designing, problem solving. And so we're trying to teach those students how do they take the fundamental skills they already have, whether it's math skills or science skills, and start to apply those to real-world problems.
When I returned to college, I had not really passed a basic algebra class. I was very, very new to math in general, so I had a lot of reservation about returning to school and being bombarded with information and technology that I'd never had my hands on before.
Software accessibility is a huge thing for our students because that's something that they can take home with them without a huge cost attached to it.
Since I've come back to school and been introduced again to CAD software, and specifically to Fusion 360, it is so intuitive and easy to use and welcoming that I can explore with it anytime I need to. It's just a really accessible tool. So when I was first exposed to generative design through Fusion 360, one of the very first things the instructor talked about was the fact that you could use less material to do the same job. Being environmentally conscious and wanting to save resources and make things lighter at the same time and more accessible, that was it. That was all that it took, was you can use 35% less material if you use this system to design your parts. First thing I think of now when I design in CAD is, can I apply generative design to this? It's a critical part of our education to understand material science and use, and going forward we know that we need to use less and we need to do more with less. So sustainability in manufacturing, I don't even know if they can exist without each other going forward. And the piece that we're opening is a 3-axis puppet controller designed to be 75% lighter and contain at least 50% less components than the original. I achieved that by reducing the parts to 1/3 of the original and the weight from 25 kilograms down to about 5. It's amazing to be able to design something that is so futuristic and so bleeding edge, and to be able to open a box and pull out this thing that's not only exactly what you saw on the screen, but exactly what you hoped for on the screen. It weighs less, it functions better, it looks incredible.
It always makes me feel very accomplished as a professor when I see students like Justin come to me and explain to me what they're working on, and I've lost the ability to understand it.